Okay, this is second semester math 7, lesson 10. Tomorrow we have a quiz. Vocabulary review. How is find the percent of a number like multiplying decimals? Who's got that question? How is finding the percent of a number like multiplying decimals? Miriam.
You turn the percent into a decimal, then you multiply it by the number.
Okay, very good. So you convert a percent into a decimal. And how do we convert a percent into a decimal?
You move the decimal point 2 places to the left.
Yep. We move the for a percent to a decimal, you move the decimal places 2 places to the left. Okay, and once you have it a decimal, you multiply it, and that is the percent of that number. Very good. So here's what the book has. They actually give an example with it. Every percent can be written as a decimal by moving the decimal point 2 places to the left. Thus, 25% becomes 25 hundredths. So taking the percent of a number is the same as multiplying by a decimal. So who has number 2? Who can share with us how we got number 2? Now, you might have used proportions, and that is one way to do that, but who can tell me how they got this? Attila?
I got 90, and I turned the percent into a decimal.
Okay.
So it's equal to 0.25.
Very good.
Good afternoon, CPA students and staff. Will the following 10th graders please report to the library? Will the following 10th graders please report to the library? Barry Rawls, Lola Harris, Kendall Brown, Anand, Amaris Green, Erica Kaiser, Jordan Tillman, Edeze Uwandu, and Jalen Thomason. Those students, if you could please report to the library at this time. Thank you.
Right. So if you multiply the decimal equivalent of 25%, which is 2,500 by 360, you get 90. Okay. Now, over here, you could have solved this setting up the proportion. Do you guys see the proportion? I could have set this up this way, and I'm just showing you both ways because today's lesson you can use either way. Okay? And when we solve a proportion, how do we solve a proportion? Use the cross products, and then you solve for the unknown. Okay? So for number 3, who can tell me their answer for number 3? Leah.
I found 216.
216, how'd you do that?
I used the proportion, and I turned the percentage, which is 60, I turned it into a fraction.
Okay, you made a fraction, so what was that going to be?
60 over 100.
60 over 100. Okay, and then 60 over 100, what did you do with that? What was the other side of your proportion?
And then the other one was x over 360.
X over 360, very good. Now, if you had set it up without a proportion, you would have just multiplied 6/10 is the same as 60%. Or you could have written that as 60 hundredths, but then you just have an extra digit there. If you multiply that, it gives you 216. You use the proportion, you still got 216, correct? And so just so I can have this in the notes, 60 is the part of 100, which is the whole, and that equals, in this case, I'll just use a different variable, y over 360. And if you solve that proportion, you get the same answer, which is 216. Okay? Any questions? Okay, so either of these will get you the right result. All right, so this last one, who has number 4? Who can tell me what they got for number 4? Go ahead, Thomas. 259 and 2/10. Very good. Did you do that by multiplying it?
I did not.
What'd you do?
I took 50% of it, multiplied 10% by 2, then got 1% and multiplied that by 2 and added it all together.
Okay, so you figured out 50%, then you figured out 10%, you multiply by 2 to get 20%, and then you got 1% and you multiply that by. That's a lot of mental math, but that's okay. Let's go ahead. If you have another way to do it, great. There's going to be more than one way, but I just want to focus on the 2 methods, which is rewrite my percent as a decimal. How do I rewrite my percent as a decimal? What's it going to be? Left 2 places, but what's that end up being? 72 hundredths. When you multiply that out, here's what you got, which is exactly what Thomas gave me. Now, you could set this up as a proportion, 72 over 100. That equals, I'll just say z for this one, z over 360. If you solve for z, you still get 259 and 2/10. Any questions? All right, moving along. Here we go. All right, so what you'll learn, to analyze and construct circle graphs, new vocabulary, circle graphs. Why learn this? You can use a circle graph like the one below to display survey or research results. You can see at a glance how the parts compare to one another and to the whole amount. All right, so here's our circle graph, and this circle graph represents what? The different genres that people buy for music, right? And then what would 100% be? How much, does it tell us what 100% would be? They just tell us the percentage, so they're not telling us like how much is spent on this music, right? Now, if I were to add up all of these different sections, what would that give me back? 100%. Let's check it. So in purple, I have 36 and 5/10%. In green, I have 24 and 4/10%. And then over here in yellow, I got 22%. Over here, I got 10 and 5/10%. Then I got 3 and 4/10, and then I got 3 and 2/10. Okay? So if I add that all up, let's add up this right-hand column. 5 plus 4 plus 5, 14 plus 4, 18 plus 2, 20. I bring my decimal down, carry my 2. 6 and 2 plus 4 plus 2 more plus 3 plus 3 more. That's going to be 20 again. Carry the 2. 2 and 3 plus 2 plus 2 more plus 1 more. 10. That's 100%, right? Okay, so just know that in a circle graph, all of these different sections add up to be 100%. Now let's read about the definition of a circle graph, because we don't like to call these sections, we like to call them something else. A circle graph is a graph of data in which a circle represents the whole. So all of these sections together represent the whole circle, 100%. Each wedge or sector, so we don't call them sections, we call them sectors or wedges, is part of the whole. The total must be 100%, like we showed earlier. You can use a circle graph to see how the whole breaks down into parts. All right, so here's what we have. We're going to use this same, graph, but for this graph, what we're going to do is we're going to calculate the sales for country music. So country music is 10 and 5/10% of the total sales when it comes to music. Now, if in a recent year consumers spent 13 and 7/10 billion on music recordings, we're going to use the data from the circle graph below to find how many dollars to the nearest tenth of a billion were spent on country music. So here's the percent spent on country music. I need you to calculate how much to the nearest tenth of a billion was spent on country music. So this is just the warm-up. And there's a couple ways to do this. You might be able to mentally figure it out. Did anybody find it? What'd you get, Leah?
I got 143.
143. So let's go ahead. When we multiply it, we're multiplying by that decimal. Is that what you guys got? Okay. All right. Now, some students in the earlier classes, they only moved it 3 places. And they're pretty insistent, like, no, it's only 3 places. What'd they forget?
The first one.
They forgot about the decimal place on 13 and 7/10 billion. Okay, there's a place value here that the decimal is over 1. So the 3 for the percent that's written as a decimal, but then the 1 place for here for the 13 and 7/10 billion, right? That's why I move it 4 places. Do you understand why the decimal is where it's at? So if that's you, is there any question about how you figure out how many places to move the decimal? We're good? Now, the question, that's not the answer to my question. The question says round to the nearest 10th of a billion. And this is a little bit of review, and I feel like some students forgot how to round to the nearest place value. In this case, the 10th place. Can somebody remind the class, how do we round to the nearest 10th place? Who can tell the class how to round to the nearest 10th place? Kimberly?
Well, you look at the hundreds, and if
Okay, so generally, if you're rounding to a place, you're going to look to the one to the right. In your case, you said the nearest 100. You're going to look at the hundreds place, so that's correct. So 4 is in the tenths place, and the hundreds place, we have 3. Okay, so now we're looking at the hundreds place, and we see a 3 there. Now what?
so if it's 5 or over, then the tenths place it rounds up. But if it's 4
Round up by how much?
by 1.
By 1. Okay, so if the number in the hundreds place is 5 and up, we round the number in the tenths place up by 1. If it's not,
If it's not, then you just keep the number in the tenths place the same.
right, so if the number is not greater than 5 or more, then we just drop off those digits and we keep the number in the tenths place the same. So in this case, my answer to the nearest tenths of a billion is going to be 1 and 4. 1 and 4/10 billion is spent on country music. Are we good? Okay, so let's move along. And then here's the next thing we're going to do. That was kind of us working together. Let's try to work this one out. It says approximately how much money was spent on jazz. So we have to identify in the circle graph what percentage was spent on jazz. Then you have to use that to calculate the amount to the nearest 10th of a billion spent on jazz. Do you have a question?
I can't really see it.
You can't find jazz?
I know it's the dark blue, but
Right, is that better? Can you see it now?
I don't know. Make my phone.
It's 3 and 4/10%. Got it? When you're done, if you could put your pencils down. Okay, looks like a few of you are still working. Almost everybody's done. Okay, I'm going to go ahead and go over the answer with you. Who wants to share with the class their answer? Can I get a volunteer? There's a few of you that put your pencils down like, I know this. I'm done. Somebody new? Ben?
No, I messed up.
Oh, you see an error?
Yes.
Bokar, do you know it? You multiplied what? Okay, you moved it how many places? 2 places, so what'd you multiply by? And what was the decimal value of the percent? Do you remember the name of that word or that number? For the percent equivalent of 3 and 4/10%, the decimal equivalent. You moved it to 2 places, but what do we call that number? 34 thousandths. So we're going to multiply that by 34 thousandths. And then what did you get when you multiply by 34 thousandths? Okay. So you got 4,658 tenths, hundredths, thousandths, 10 thousandths. So 4,658 10 thousandths. But we need to round to the nearest tenths. So what's it going to be? Right. So in the hundredths place we have a 6. That's 5. So that's more than 5. So we're going to round up by 1, and then we're going to drop all the other numbers off. So that is $500 million, or 5/10 of $1 billion. Okay, are we good? Any questions about that? Okay. All right. Now I have in here a protractor. There's a reason for that. Let me get you guys really quickly. So in the last example, they told us the total amount spent on music altogether, right? How much was it? 13 and 7/10. Is that what it was? Okay, so they gave you the total. They gave you the whole, right? Well, in this problem right here, they're not going to give us the whole, so you have to figure that out. So let me go ahead and read this to you. A circle graph is divided into sectors, or we can also call those sectors what? Because of the W, wedges. Each sector is determined by a central angle. So we're going to try to figure out what our central angle is so we can make a circle graph. Now, in Connexus, you're not going to be expected to make a circle graph, but you might be expected to calculate the central angle. So that's what I'm going to walk you through. But I'm also going to draw the circle graph. So, analyzing a circle graph. Science is the topic. Use the information in the table below to make a circle graph. So, this table is the NASA Space Shuttle expenditures. So that program has been broken into 4 places for the budget. So for the first part, the orbiter, they spent $698 and 8/10 million. For propulsion, do you guys know what propulsion is? What's propulsion? What are they talking about when they're talking about propulsion? Yeah. Hey, that's a good idea. Propeller has to do with something. Propeller does what in a boat? What does a propeller do if you're in a boat? I like that you're using root words. That's a good word. The word of tech skills. What does a propeller help you do in a boat? Helps you move, right? So when we're talking about propulsion, we're talking about moving. How do we move a space shuttle? With the rockets, right? The big tank, and then you have the rockets on the side, and the orbiter's attached to it. The space shuttle's attached to it. Okay, so most of the money is spent on propulsion. And then you have operations. Operations would be like ground control, the people, the support crew. Does that make sense? That's the second most largest part of your budget. And then the least is upgrades. So upgrades would be like maybe upgrading computer systems on the orbiter, upgrading the computers in the ground control, maybe the radio systems. So those are the 4 areas. Now, can you guys really quickly find the sum so we know the total? Because that number is important to us. And just so everybody remembers, how do we find the sum of decimal numbers? What do we do? So we just reviewed finding the product of decimals. How do we find the sum of decimals? Nicole, do you remember how to find the sum of decimals? How do we do that?
We basically as in whole number and nominal decimal, or if it's a normal decimal without any whole number to it,
It's actually easier than that. Can somebody help her out? Zainab? You have to line up the decimal. Got it, Nicole? You just line up the decimal. I know what you're trying to say, but you're using a lot of words, and I was trying to streamline it for you. I know where you're going. Line up the decimal, okay? And while you guys are going through your calculations, I will go through my calculations. check my work. Is that what we got? Okay. Now that's important because we need to calculate the central angle. So that's the sum of all of the data we have. And do you guys remember at the beginning I said, hey, look, there's a couple ways you can do those warm-up exercises. You can set up a proportion, or you can do it another way. For here, I feel like the easiest way is to set up a proportion, but you might know another way. So if you take the part, in this case the orbiter's budget was, or the cost of the orbiter's portion of the budget was $698.8 million over the whole, which is what we just calculated, all right, the entire budget, equals, do you guys see why I have A over 360? Because I'm trying to figure out what degree of the whole, which is 360 degree, does that wedge, what's that central angle going to be for that wedge? Ben? Yes, go ahead. I'm not worried about you guys doing this right now. You guys know how to solve proportion with the cross products. Do you guys remember that? Okay. So it's approximately equal to, the central angle is going to be approximately 84 4/10 degree. Now I'm going to go ahead and show you the other categories. Here are the other categories. All right. So this would be the orbiter. And then the next one I did was what? The propulsion. Okay, and then the next one was operations. Okay, and then the last one, upgrades. Okay, so I'm going to draw this using my protractor. The first angle for the orbiter, I have a key over here. The orbiter is in blue, so that wedge I'm going to color blue. And so I need my wedge to have a central angle of 84.4 degrees. So I'm going to go ahead. That's 80. 1, 2, 3, 4. And this is going to spit out the angle that I want. And it tells me 84. So I'm going to go ahead and put this here. And notice where I put my vertex. You guys see that? Okay, so that is 84 degrees. Okay, and I need to shade that what color? Blue. Okay, and then the next thing I'm going to do is propulsion. And propulsion is not shaded. That's just going to be white, but that's going to be 127 2/10 degree. And is that an acute or an obtuse angle? Obtuse. So 125, 6, 7. 127 degrees. And so I'm going to shrink this down, rotate it, so that I can get this to fit. Okay, and what am I supposed to shade this? Propulsion is no shade. It's white. So now I got to calculate my operations. And what color am I going to shade operations? Red. And it says 89 3/10. So that's almost 90 degrees. And let me see. Here's 90. Nope, don't want that. I need one less than that. Okay, I think that'll be it. 89 degrees. Okay, and I'm going to put that wedge right here. Let me shrink that down a little bit. and that was going to be red. That's operations. So we'd shade that in red. And the last one is going to be upgrades, which is green. That's 59 and 1/10 degree. So 40, 50, that's 60. Okay. Nope, I don't want that. Wrong one. 59. There you go. Here's 59. Let me rotate that around. It should fit, right? Because they should be pretty close. Remember, I couldn't go to the nearest 1/10 of a degree. Closest I can get was the nearest degree. But it should still fit pretty good in there. And it does appear to fit pretty good in there, right? And that has to be, what color is that going to be? Green. Okay, so do you see how we're going to draw a circle graph? You guys understand? We calculate the central angle, and that's from the percent. Okay, so now what I need you guys to do, let me go ahead and move this out of the way when I have the notes. Okay, now what we're going to do is we're going to do our own. Summer, spring, winter, and fall. These are the favorite seasons for some people. 40% of the people surveyed liked summer the most. 11% liked spring. 4% liked winter, and 45% liked fall. So can you use this to calculate the central angles so we can make our own circle graph? Can you wait till she gets back? Okay, so how would you find the central angle that would represent summer? Can somebody tell me how we would do that? There's a couple ways to do it. There's two ways. Think about what I showed you in the warm-up. What's one way?
First we have to add up all the
Right, but we know that all the percents are going to add it to what? To 100, right? So we already know all the percents will be 100. So what else are we going to do?
we will make a proportion.
Okay, so what would the proportion be?
40 over 100
Okay, 40 over 100.
equals x
Uh-huh.
over 360.
Nice, x over 360. So this looks a lot like the warm-up. The other way I could have done this is what? Does somebody have another method? What did you find to be x? What was x for you?
X was
144 degrees. Okay, so can somebody tell me another method? What's the other method I can use here instead? Can somebody tell me the other method? Think about the warm-up. I could change 40 into a decimal, so I would take 360 and I would multiply by 4/10 or 40 hundredths. And that's going to give me back the same amount, 144 degrees. Okay? So summer, the central angle would be 144 degrees. Can somebody tell me really easily, if we know 40 degrees, couldn't we figure out 4%? If we know 40%, couldn't we figure out 4%? We just move our decimal over one place. So what's winter going to be? 14.4 degrees. Okay, and can you guys quickly calculate spring and fall so we can complete this circle graph? And we'll color this. We'll color code this. Summer, spring, and then fall, and then I'll leave winter white for snow. So let me go ahead and get summer. Green, summer. Okay. And that first was 144. Okay, it's 144. All right, and then we know winter is 14.4. Oops. There we go. Okay, and winter was white and summer was green. Okay, summer was green. Who got spring? What was the value for spring? Did anybody get that? What'd you get? 39 and 6/10. Okay, so that's almost 40 degrees. And then who got fall? What did you get for fall? Did anybody get fall? Yep.
I got 59
59
degrees.
degrees. Okay, so let's go ahead and see if this all fills up. So I got 39, almost 40 degrees. I'll just go ahead and make that 40 because it's pretty close to 40. And what do we shade this one? Is that a mistake? What's that? I shade it blue? Okay. So this one's going to be blue. It's not right. It's not 39.6. What is it?
It's 162.
162? Anybody else get 162? For 11%? Now wait, hold on a second.
Fall would have to be greater than summer since it's 45 to 40.
We're talking about spring though, right?
We're talking
No,
about
but
fall.
we're talking about fall is wrong.
Fall is wrong. That's not 59.
How much is fall?
162.
We're talking about degrees, ladies and gentlemen. It would have to be just a little bit more than 144 because this is 40, right? So what did you guys get? 162 even?
No, .05.
0.05 or 0.1 then, right? To the nearest tenth of a degree. So 162.1. All right. So let's see, it should fit. We'll check it right now. 162, so that's 90, 100. That's 160. Is it 162? No, I got 161. Let me delete that. Okay, I think that's 162. I got 162. So if we're right, this will fill up the rest of my circle, right? Okay, and what do we shade that? That's fall, right? So we shade it.
Well, it was supposed
Fall is.
fall was supposed to be white.
Oh, I mixed it up. Winter should have been red.
Yeah.
Okay, I'll make fall. Oops. Winter is red, fall is white. So here we go. That little wedge right there. Okay, last slide. We're almost done. In a circle graph, the sum of the sectors must equal what?
100.
100, or what about degrees? 360. Here's what the book gives. The whole circle, 360 degrees, or 100%. Okay, now take a look at this. A circle graph has 5 sectors. 2 sectors are equal to 25% each. The third sector is 35%, which cannot be the value of the remaining 2 sectors. We're almost done. Any ideas? Answer this. Answer this question. Answer this question. What's that? Somebody that was following along. Leah, go ahead.
22%.
Why'd you say 22%?
Because when I added 50 and 35, it equaled 85.
Right, so you got 50 because you had 2 sections at 25. That's 50. Plus the 35 is what?
80.
So this, I wrote it up here. So you add them up, you get 85. And then you take that away from 100%, you have 15% left over, right? So which of these could it not be? It can't be 22% because all you have left over is 15%. So find the measures of the central angle you would draw to represent each percent in a circle graph. So I need to figure out what would the central angle be for 25%, 50%, 10%, and 12 and 5/10%. First 2 are pretty easy. You should probably be able to mentally do that one. You could do it using proportions. You can rewrite the percent as a decimal. There's 2 ways to do this. Okay, walk me through the first problem. Walk me through the first problem. We've been doing this all period long. Walk me through it.
So 25%.
Can I get somebody else to volunteer? Marion? 90 degrees? Okay. So what did you do to get 90?
I turned the percent into a decimal by moving it to the left,
Right.
and then I multiplied it by 360.
So you turn 25% into a decimal, then you multiply by 360. Now what you could have done is you could have taken 25 over 100 equals x over 360, and you could have solved that proportion, right? Now who's got 50%? Who can tell me how they did that? Justin? 180. That's easy because you know 50% is just half. Half of 360 is 180. If you didn't know that, you could mentally calculate it. Rewrite 50% as 5/10. Multiply that. It gives you 180. Or you could have rewritten this 50 over 100 equals y over 360. Solve for y. It would give you 180. 10%. Who has 10%? That one's pretty easy too. You can mentally do that one. Athila. 36. Very good because 10% is just 1/10. 1/10 times 360 is going to be 36. And again, you could have also set up your proportion, which is 10 over 100 equals z over 360. Solve for z, you would have got 36. And then the last one, who's got the last one? Justin. It is 45 degrees. Here's how you'd figure that out. You'd convert 12 and 5/10% into 125 thousandths, tens, hundreds, thousandths. You get 45. Or you could rewritten this 12.5 over 100 equals W over 360. And then solve for W. That would have given you the same answer.